Hi everybody! So in today's video, we are going to be learning lesson 6 from unit 2, which is all about how to take derivatives of exponential and logarithmic functions. So what we're going to start right now with is just exponential functions, and our target for today is going to be to calculate the derivative of trigonometric, exponential, and logarithmic functions, but today we are specifically focused on exponential and logarithmic functions. So let's start by learning a few derivative rules. So let's start with this. An exponential function is any function of the form where you have a number to the power of x. So that's what makes an exponential function, is that the variable is in the exponent, which is why we call this exponential. So the way that we show this kind of in general terms with the a, where the a can represent any number. So it could be a 2 or a 3 or a 4, and an example of an exponential function would be 3 to the x power. So let's start by learning the basic rule. The rule for the derivative of an exponential function is that the derivative is equal to the original function, so a to the x, times the natural log of the base of the original function. In this case, the base is a. For example, if we asked you to find the derivative of f of x is equal to 3 to the x power, we would say that the derivative is just 3 to the x, so the original function, times the natural log of the base, which in this case is 3. So that is your derivative. Now, a special case of this comes up when our base is e. As a reminder, e is just a number. It's approximately 2.718, and that's Euler's number. So that's kind of the natural number that occurs in nature. And when we take the derivative here, we apply the same rule that we used before. So because e just represents a number, our derivative would be e to the x, the original function, times the natural log of the base, which in this case is e. But here's what makes e special. The natural log of e is always just equal to 1. So since the natural log of e is just equal to 1, we can actually simplify this and rewrite it as just e to the x. In other words, if I ask you to take the derivative of e to the x, the derivative is just e to the x, because the natural log of the base in this case is always going to simplify to 1. Let's do a few example problems so that we can see how this might work with a combination of product rule, quotient rule, and chain rule, in addition to sort of this new exponential rule. So for problem number 1, I think it's important to realize that this is a chain rule question. The outside function is that we have e to the something, and the inside function here would be that we have 3x instead of just x. So chain rule says start by taking the derivative of the outside. So I would say y prime is equal to, and then the derivative of e to the something is just e to the something. Now we could put times the natural log of e, but what we should know is that the natural log of e is always just 1, so that part kind of cancels each time. Now we're going to leave the inside alone here, and then we're going to multiply by the derivative of the inside, which in this case would just be 3. Now the more common way you're going to see this written as your final answer is that you're going to see the 3 moved to the beginning like a coefficient, which means your most common way you're going to see your answer here is just 3 and then e to the 3x power. All right, let's try another one. For problem number 2, we have 5 to the x power. In this case, there is no chain rule. There's nothing weird going on. There's no product rule or quotient rule. So we can just apply our straightforward derivative of an exponential function rule, which in this case would be f prime of x is equal to. Now the rule for an exponential function says you just copy the original, 5 to the x, times the natural log of the base, which in this case is 5. And again, we didn't need the natural log here because the natural log of e is just 1. Even though that is following the same rule, it just simplifies. Let's try problem 3. Now in problem 3, again, I think it's important to realize that this is a chain rule question. So the outside function here would just be 5e to the something, but the inside function here is negative x, and it's important to realize that there's an invisible -1 there. So when we take the derivative, we have g prime of x is equal to, the derivative of 5e to the something is just going to be 5e to the something because the derivative of e is just itself. And we're going to leave the inside alone. So negative x times the derivative of the inside, which is -1. That's the chain. Again, we're going to simplify this. So what you're normally going to see is that the -1 gets multiplied by the 5, which means typically the way you'll see this final answer written is that g prime of x is equal to -5e to the -x. For problem number 4 here, we have, again, an exponential function, but this one does have chain rule. So we're going to have 4 to the something is the outside function, and the inside function is 2x minus 1. When I take the derivative here, I'm going to start with the outside function. So the derivative of the outside would be 4 to the something times the natural log of 4. And we're going to leave the inside alone, which is going to be 2x minus 1, times the derivative of the inside, which is 2. Now, some students make a mistake here and think that they can multiply the 2 times the 4, but you cannot do that because the 2 and the 4 are not both the base of the 2x minus 1. So if you wanted to write the 2 at the beginning, the more common way you might see this written is that you might see this written as 2 times, and then you could put separately 4 to the 2x minus 1 power times the natural log of 4. Next, we're going to look at some problems where we use a combination of these exponential functions as well as some trigonometric functions and product rule and quotient rules. So for problem number 5, we're going to use product rule. The two different functions here are sine and e. So product rule says that we're going to start by copying the first, which would just give me sine, taking the derivative of the second, and the derivative of e to the something is just e to the something, plus, and then we're going to copy the second, which is just e to the t power, and then take the derivative of the first, which would just be cosine of t. And that would be your answer. For problem number 6, we're going to use a combination of quotient rule, exponential functions, and trigonometric functions here. So my top is going to be 4 to the x power, and my bottom is going to be tangent of x. If you need a refresher, I like to sing a song for quotient rule, which goes low d high minus high d low, and low squared goes down below. So we would start with the low, which is tangent of x, d high, and the derivative of 4 to the x would be 4 to the x power times the natural log of 4, minus high, which is 4 to the x power, d low, the derivative of tangent would be secant squared of x, and low squared, which is tangent, goes down below. So in the denominator, we would just put tangent of x quantity squared, and that would be my answer. Now, the second thing we need to talk about today is how do we take the derivative of a logarithmic function? So now that we've learned about exponential functions, we're going to learn about logarithmic functions. Again, we're going to start by learning sort of the general logarithm function rule, and then we will focus on a log whose base is e, which we call natural log. So as a reminder, the natural log is really a logarithm whose base is e, which is we simplify and we just write natural log. So the derivative of a logarithm function where a is the base is going to be 1 over whatever is inside, so whatever's inside the parentheses, times the natural log of the base, which is a. An example would be that if I asked you to find the derivative of log base 3 of x, I would say that the derivative is going to be 1 over whatever is inside, so x in this case, times the natural log of the base, which is 3. Now, we're going to go ahead and use that same rule to figure out how to find the derivative of natural log, but just like when we found the derivative of e to the x, we're going to find that this derivative simplifies a little bit to make it a little bit easier to find it. So the derivative of natural log, if we follow this rule, would be 1 over x times the natural log of e. And just like before, the natural log of e simplifies to just 1, which means the derivative simplifies to just 1 over x. So what I like to do is I like to say it's just 1 over the stuff, whatever's inside. What I would say here for the derivative of 3 times natural log is I would have 3 over x. And the reason I would have 3 is because that coefficient just goes on the top, and the derivative of natural log just says put the stuff in the denominator, 1 over the stuff. All right, let's try a couple examples. So for problem 7, it's going to be a chain rule question, and the outside function here is the natural log function, and the inside function here is the 3x. So if I take the derivative, y prime would be equal to, the derivative of natural log is going to be 1 over the stuff, which in this case is just 3x. And then we're going to need to apply the chain rule, which means multiply by the derivative of the inside function, which is 3. What that's going to do is give me 3 over 3x, which simplifies to, again, just 1 over x. For problem number 8, we're going to use just our regular logarithm rule. So the derivative of log base 5 of x would just be 1 over the stuff, which in this case is x, times the natural log of the base, which is 5. For problem number 9, we're going to be taking the derivative of a natural log function, but again, this is going to be a chain rule question. So the outside function here is the natural log function, and the inside function is 4x plus 5, which means the derivative is going to be the derivative of natural log, which is just 1 over whatever the stuff is. In this case, that's not going to change. It's just going to be 4x plus 5 times the derivative of the stuff, which is 4. And we can rewrite that with just the 4 in the numerator. So it'd be 4 over 4x plus 5. For problem number 10, it's a logarithm function, but this time we're going to use chain rule because the inside is 2x minus 1, not just x. As a reminder, if you ever see a log like this where there is no base written, then that means we have log base 10, which we call the common base. So what we would do is rewrite this as log base 10, and then the inside function would be 2x minus 1. The derivative would be 1 over the stuff, which in this case is just 2x minus 1, times the natural log of the base, which is 10. And again, the stuff doesn't change. Chain rule says take the derivative of the outside, leave the inside alone, times the derivative of the inside, which is 2. So if I wanted to write this in a simpler way, you might see it written as 2 over parentheses 2x minus 1 times the natural log of 10. For problem number 11, again, we're going to deal with chain rule here, but in this case, the outside function is log base 2, and the inside function is sine. So to find the derivative, I would start with the outside. The derivative of log base 2 would be 1 over the stuff times the natural log of the base, which is 2. And the stuff here is just sine of x. Then the chain rule says multiply by the derivative of the inside, which would be cosine of x, which means we could simplify this by writing cosine of x on the top over sine of x on the bottom times the natural log of 2. For problem number 12, we're looking at a product rule question where the first function is e to the x and the second function here is natural log of x. So if we find the derivative, we would have copy the first, which is e to the x, times the derivative of the second. The derivative of natural log is just 1 over the stuff, plus, then we would copy the second, which is the natural log of x, times the derivative of the first, and the derivative of e to the x is just e to the x, and that would be our final answer. Okay, thank you guys so much for watching, and I will see you for some practice in class.